Welcome to e-lecture video section on Quantitative Aptitude, Chapter 11, Part 3 of Measures of Central Tendency. Myself, Dr. N.V. Ravi, I'm mentor for this section. In this section, we are going to discuss on mode, geometric mean and harmonic mean. Now coming to the mode is defined to be as the value occurs the maximum number of times. Generally, mode is the definition maximum concentration of the observation around it, which is very much useful in the garment industry and shoe manufacturing industries. If you want to find out the maximum number of observations, suppose in the series 5, 3, 5, 5, 5, 3, 2, 1. In this, 5 is repeated 3 times, so mode is the 5, which is very useful in the industries like garments and shoe manufacturing industries. Now, mode is for finding the ungrouped data using the class intervals like that. Mode equal formula. Now we may consider the following formula for mode for ungrouped data as follows. Mode equal to, now see the example related to mode for ungrouped data. The data is 50, 60, 35, 40, 56. In this example, there is no model class here, so there is no number of repeated. So we can say that there is no model class for here. Now coming to the data related to mode for grouped data. Now the mode can be found out using the following formula. Mode can be defined by letter Z, L1 plus F0 minus F minus 1 by 2F0 minus F minus 1 minus of F1 into class interval. Here, where L1 equal to LCB of the model class, L1 equal to lower control boundary of model class, and that is the class containing mode, and F0 equal to frequency of the model class, frequency of the model class, F minus 1 equal to frequency of the free model class, and F1 equal to is frequency of the post model class, and C is the class length of the model class, class length of the model class. Now look at the example related to grouped data for mode. The data is as follows. Now the class intervals, data and frequency are given. The class interval is 350, 369, frequency is 23, 370, 389, 38, 370, 409, 58, 410, 429, CET2, 430, 449, 65, 450, 469, 31, and 470, 489, 11. Now coming to the point related to mode, let us see the frequency of the data. The highest frequency we called as model class, which is we assume to be F0, and pre-model class above this one is F minus 1, and post model class is 65, this is F1, and respective, this is the data of the class interval of inclusive. This data is changing to exclusive class interval class. After that, this will be the lower boundary of class will be 409.5 and upper boundary is 428.5. Now we have to use this in the formula, and now look at the mode formula as follows in the next slide. Mode for the given data, Z equal to L1 plus F0 minus F minus 1 by 2F0 minus of F1 minus F minus 1 into length of the class interval. If you look at this earlier table in the column, we have already found that F0 is, that is model class is 82 and F minus 1 is 58 and F1 post model class is 65, and the model class and a class against the highest frequency, thus lower control boundary is LCB is 409.50 and length of the class interval is 429.50 minus 409.5, which is 20, and mode equal to, hence the applying formula, all these things here above, mode equal to 409.50 plus 82 minus 58 by 2 into 82 minus 58 minus 65, and length of the class interval is 20. After simplifying this value, this will become 421.21. So Z mode is for the grouped data using the formula, that is mode equal to L1 plus F0 minus F minus 1, 2F0 minus F1 minus F minus 1 into C. Simply we found the first model value. After that, the pre-model value is this one, and this one is post model value, and length of the class interval, lower, and LCB values. After that, substitute all the values in the formula, that is mode formula is this one, then we get the value. In the case of ungrouped, mode in the case of grouped data. In the earlier slide, you have seen the example related to grouped data. When in the case of mode for the ungrouped data, the formula for mode, the mode can be Consider the following empirical relationship when mean, median, and mode are known. Mean minus mode equal to 3 times mean minus median. This is the empirical relationship between mean, median, and mode when 3 are known. Now coming to the point related to mode equal to 3 times median minus 2 times mean. This is also very important formula. Mode equal to 3 times median minus 2 times mean. Now look at the example for a moderately skewed distribution of marks in statistics for a 200 students. The mean marks and median marks were found 55.60 and 52.40. Now here the 55.60 is the mean and 52.40 is the mode. Now we have to find the model mark using the formula this is 3 times 52.40 minus 2 times 55.60. Now after simplifying this, 46 is the model class for this data. Even for the examination point of view, students can look at these two formulas, very important. The empirical relationship between mean, median, and mode is mean minus mode equal to 3 times of mean minus median. When median and mean are known, mode equal to 3 times median minus 2 times mean. Now coming to the example related to mode, if y equal to 2 plus 1.50x and mode of x is 15, what is the mode of y? This is the property comes under mode also. Here y mode we have to find y mode equal to 2 plus 1.50 of x is the given. Here this x place mode of x is 15 has given. Simply 2 plus 1.50 into 15, which is 22.5 plus 2, 24.50 y of mode. These kind of things, MCQ's point of view, very important. Y equal to a plus bx linear relationship here mentioned. Simply in the place of x you have to substitute x value mode, then add that intercept also, then y mode will be getting. These are the very important for the examination point of view, in the very important MCQ point of view also. What is the model value of the numbers 5, 8, 6, 4, 10, 15, 18 and 10? Let us look at the data. Here the 8 is repeated only one time, 5 is repeated one time, 6 is repeated only one time, and 4 is also repeated one time, and 10 is repeated 2 times. So rest of the values are repeated only one times. For based on the definition of mode, the maximum number of items repeated items is 10 only. So mode is 10 for this data. Mode is 10. Now coming to the MCQ2, if x and y are related by x minus y equal to 10 and mode of x is 23, then mode of y. Already we have discussed in the earlier slides, there is a linear relationship between x and y also. Now look at the data. X minus y minus 10 equal to 0, x minus y equal to 10, x minus 10 equal to y. We want to find the mode of x is to be 23 also given. Then y mode we have to find 23 minus 10 equal to y. Then y mode is y equal to 13. So mode of y is 13. Answer option B is the correct. Now look at the MCQ number 3. For a moderately skewed distribution, which of the following relationship holds? First one, mean minus mode equal to 3 times of mean minus median. Second option, median minus mode equal to 3 times of mean minus median. Third option, mean minus median equal to 3 times of mean minus mode. Mean minus median equal to 3 times of median minus mode. Already we have discussed the property relationship between mean and mode and median. In the case of when the grouped frequency distribution, we may consider that mean minus mode equal to 3 times of mean minus median. Option A is correct answer. Now coming to the geometric mean, which is based on the mathematical properties. Geometric mean is very much used in the case of distance properties. When the distance is constant, speed varies, then we use the formula average called geometric mean. For a given set of n positive observation, geometric mean is defined as nth root of the product of the observations. Thus, the variables x assumes n values. Suppose there are values x1, x2, etc. n as xn observation. All the values being positive, then geometric mean consider as x1 into x2 into x3, etc. xn whole to the power of 1 by n. And for a grouped frequency distribution, the geometric mean can be defined as x1 to the power of f1, x2 to the power of f2, x3 to the power of f3, xn to the power of fn whole to the power of 1 by n. 1 by n is nothing but sum of the frequencies. N equal to sum of frequencies, that is f5 in the case of grouped frequency distribution. Let us look at the properties related to geometric mean. Logarithmic of g for a set of observation is the am of the logarithmic of the observation. Log g equal to 1 by r of summation of log x. That means here logarithm of g equal to 1 by r of summation of log x. If all the observations are by a variable or constant, say greater than then gm of the observations is also constant. Gm of the two variables of the product there, gm is equal to z equal to xy, then gm of z equal to gm of x into gm of y. This is the important property you have to remember. And gm of the ratio of two variables is the ratio of the gm's of the two variables z equal to x by y. Then gm of z equal to gm of z equal to gm of x by gm of y. Gm of x by gm of y. These are the important properties. Here log g equal to 1 by r of summation of log x, one property. And if all the observations are assumed to be variable or constants, then gm of the observations are also k constant. and GM of the product of two variables, product of their GMs is Z equal to XY, GM of Z equal to GM of X into GM of Y, and GM of the ratios of two variables is the ratio of the GMs of the two variables Z equal to X by Y. These are the important properties. Let us look at some of the important examples. The example is GM of 3, 6 and 12 we have to find. Now we have to find the values as follows. The given data is 3, 6, 12. For this we have to find the GM, geometric mean. Geometric mean is the nth root of product of values. Suppose 3 into 6 into 12 whole to the power of 1 by 3. And here if you look at this data, 3 into 6 into 12 can be written as 6 into 12 whole to the power of 1 by 3. Now these 3 2's are 6, so 6 into 6 into 6 whole to the power of 1 by 3. If we look at this, 6 is repeated 3 times, 6 to the power of 3 whole to the power of 1 by 3. This 3 one time, so 6 is the geometric mean of the values 6, 6 and 12. Now look at the example related to geometric mean in the case of grouped data. Here x values are given and y values are given, and already we have seen in the case of geometric mean formulae for grouped frequency x1 power f1, x2 power f2, x3 power f3 whole to the power of 1 by n equal to 1 f1 plus f2 plus f3. But here 1 f1 f2 f3 f4 frequencies. If 2 plus 3 5, 5 plus 3 8, 8 plus 2 10. This is the n. Here I have given that in the case of example related to 3 frequencies. But here the data is 4 bivariate data, and the geometric mean simply as follows: 2 to the power of 2, 4 to the power of 3 and 8 to the power of 3 and 16 to the power of 2. These are all whole to the power of 1 by 10, because sum of these all frequencies is 10. Now let us look at the simplification part of this. If you look at this 4, 8 and 16, all are multiples of 2, where can simply write in the form of multiples of 2. 2 to the power of 2 and whole to the power of 3, and this 8 can be written as 2 cubed whole to the power of 3, and 16 can be written as 2 to the power of 4 and 2 and whole to the power of 1 by 10. And this is 2 to the power of 2. 2 to the power of 2 and 2 to the power of 6 and 2 to the power of 9 and 2 to the power of 8 whole to the power of 1 by 10. We all know that is a to the power of m whole to the power of n, a to the power of mn. 2 to 3s are 6, 3 3s are 9, and this is 2 to the power of 4 2s are 8. You know, other formulas is a to the power of m into a to the power of n equal to a to, first we have applied the formula a to the power of m whole to the power of n is a to the power of mn, Second formula is a to the power of m into a to the power of n equal to a to the power of m plus n. These are all fundamental laws in arithmetics. Now look at 2 to the power of 2 plus 6 plus 9 plus 8 whole to the power of 1 by 10. And this is 2 to the power of 2 plus 6 plus 9 plus 8. This is 25 whole to the power of 1 by 10. This is 2 to the power of 2.5. 25 by 10 is 2.5, which is equal to 2 square into root 2, and 2 square is 4 into root 2, which is 1.41, and which is 5.64 is the answer. So 5.64 is the solution after solving this the data for grouped data of geometric mean. Let us look at once again geometric mean equal to, for grouped data, the frequencies are given x1 to the power of f1, x2 to the power of f2, x3 to the power of f3, and whole to the power of 1 by n. If three frequencies that are given, we are using this. But here four frequencies are given, and respective frequencies are given in the powers, that is 2 to the power of 2, 4 to the power of 3, and 8 to the power of 3, and 16 to the power of 2, and some of the frequencies 1 by 10 whole to the power of 1 by 10, and simply we write these 4, 8 and 16 respective multiples of 2, and 4 can be written as 2 to the power of 2, 8 can be written as 2 to the power of 3, and 16 can be written as 2 to the power of 4. And this will be a to the power of m into a to the power of n, a to the power of m whole to the power of n, a to the power of mn. This 3 2s are 6, 3 3s are 9, 4 2s are 8. Now 2 plus 6 plus 9 plus 8, that is 25 by 10, 2.5. This is, it can be written as 2 square into 2 power of 0.5 is root 2, that is 4 into 2 square is 4, root 2 is 1.141, that is 4 into that one is 5.64 is the answer. What is the GM of the numbers 8, 24 and 40? Now, you know very well this formula. This is the geometric mean of the three numbers x1 into x2 into x3 whole to the power of 1 by 3. Suppose three numbers are there, x1 into x2 into x3, geometric mean of three numbers is equal to the power of 1 by 3. Now look at this example, 8 into 24 into 40 whole to the power of 1 by 3. I am simply writing this 24 can be written as 8 into 3, and 8, the 40 can be written 8 into 5 whole to the power of 1 by 3. Look at 8 has come in 3 times, and 8 to the power of 3, 3 5s are 15, 3 5s are 15 whole to the power of 1 by 3. So 8 to the power 8 power 3 whole to the power of 1 by 3 can be written separately, and 15 to the power of 1 by 3 can be written separately. Now this 3 can be cancelled, 8. Again look at 3 into 5, 5 is 15, already written. So we can written as, which is cube root of 15. So 8 into 3 root of 15, this is the correct answer. Now MCQ number 2, if the AM and GM of two numbers are 6.50 and 6 respectively, then the two numbers are, we have to find. First, Here AM means two numbers is A plus B by 2 equal to 6.50. From this, A plus B equal to 6.5 into 2, that is 13. And GM of two numbers, GM of two numbers is square root of AB. Square root of AB is 6 and AB is, by squaring on both sides, 6 square is 36. Now, we have to find the two numbers. Using the algebra, A minus B whole square equal to A plus B whole square minus 4AB. You know, A plus B whole square value is 13 square minus 4 into 36, which is will be 169. 13 square, 4 into 36, 144, which is 25. A minus B whole square is equal to 25. A minus B equal to, by taking square root, A minus B equal to 5. See, students, here A plus B is find A for 13. A minus B is 5. By solving this A plus B equal to 13, A minus B equal to 5, and by adding these two, 2A equal to 13 plus 5 is 18, A equal to 9. When A equal to 9, A plus B equal to 13, 9 plus B equal to 13 implies B equal to 13 minus 9, B equal to 4. So A equal to 4 and B equal to, so A equal to 9, B equal to 4. So option B, option 2 is the correct. A equal to 9, here B equal to 4. Now let us look at the MCQ number 3. If there are two groups of containing 30 and 20 observations and having 50 and 60 arithmetic means, then the combined arithmetic mean is. Here the formula using this, the combined arithmetic mean is n1 x1 bar plus n2 x2 bar by n1 plus n2 is the formula for the combined arithmetic mean. Now here the data is, if there are two groups containing 30 and 20 observations, this is n1, this is n2, and having 50 and 60, this is x1 bar and this is x2 bar, x3, x2 bar, arithmetic mean. Then the combined arithmetic mean as follows. Then applying this in this formula, and that is 30 into 50 plus 20 into 60 by 30 plus 20, which is equal to 30 into 50, 1500 plus 1200, and 30 plus 20 is 50, and this will be 2700 by 50, 0 cancel, which is equal to 54. So 54 is the combined arithmetic mean. Harmonic mean is very much useful in the area of time and distance. When distance is constant, when the speed varies, then the average speed can be found out with the help of harmonic mean. For a given set of non-zero observation, harmonic meaning is defined as the reciprocal of the arithmetic mean of the reciprocals. Suppose the values, assume that non-zero zero values of x1, x2, etc. xn observations. It should be a non-zero values of xn observations, and we simply called as harmonic mean is hm. H equal to n by summation of that is 1 by x1 plus 1 by x2 plus etc. 1 by xn values. This can be simply written as n by summation of 1 by xi values. Now, for a grouped frequency distribution, it can be written as, in the case of grouped frequency distribution, harmonic mean can be written as n by capital N by summation of respective frequencies fi by xi. This is in the case of harmonic mean in the case of grouped frequency distribution. Now let us look at the properties of harmonic mean. If all the observations are taken by a variable or constant or k, if all the observations are variables taken by variable is a constant k, then the hm of the observations also, also k. Second property, if there are two groups n1 and n2 groups with respective harmonic means are h1 and h2, then combined hm is defined as combined hm is defined as n1 plus n2 by n1 by h1 plus n2 by h2. This is in the case of combined harmonic mean, and the harmonic mean is not applicable when the number is in a non-zero element cases only. Now let us look at the example how we can solve in the case of harmonic mean in the next slide. Now, given the example of related to harmonic mean 4, 6 and 10, how we can solve? hm is n by values of, this is 1 by x1 plus 1 by x2 plus 1 by x3 values. Here 3 observations are there, so 3 by 1 by 4 plus 1 by 6 plus 1 by 10. This is 3 by 1 by 4 is 0.25, 1 by 6 is 0.17 and 1 by 10 is 0.10. 3 by, and sum of these values 0.25 plus 0.17 and 0.25 plus 0.17 plus 0.1, which is equal to 3 by 0.52, which is equal to 5.77, and this is the harmonic mean for the given data. Now let us look at the example related to harmonic mean in the case of grouped frequency distribution. Here x is given and respective frequencies are given. You know already in the case of harmonic mean for grouped frequency distribution is n by 1 by x1 plus 1 by x2 plus 1 by x3 plus etc. 1 by xn. The n is nothing but sum of the frequencies is a capital N. Now here in the case, look at the data x is given, y f is also given. The sum of the frequency is 10 and the harmonic mean in this case here 10 by 2 by 2 n, that is f1 by x1, f2 by x2 and f3 by x3, f4 by x4. This is 2 by 2 plus 3 by 4 plus 3 by 8 plus 2 by 16. Now this will be 10 by 1 plus 0.25 plus 0.375 plus 0.125. This will be 10 by sum of all these things 2.75 and this is 4.44 is the harmonic mean for this given data. Now let us look at the relationship between AM and GM and HM. This is very important for the examination point of view also. AM is greater than or equal to, GM is greater than or equal to HM, and this is the very important relationship for the any series. This can be found out with the help of example. Now let us look at in the next slide. Compute the AM and GM and HM for the numbers 6, 8, 12 and 36. Now according to definition of AM of three numbers is, here four numbers are given, A plus B plus C plus D by 4. So 6 plus 8 plus 12 plus 36 by 4, all sum of 4, this is 15.50 is the A. And geometric mean is 6 into 8 into 12 into 36 whole to the power of 1 by 4, which is 2 to the power of 8 into 3 to the power of 4 whole to the power of 1 by 4, which is 4 3s are, this is 4 comma 2, so cancel, this will be 2 square into 3, that is 4 3s are 12, 12 is the geometric mean. And harmonic mean, already we have know the formula, this is the harmonic mean we have to find, and 4 by 1 by 4 6 plus 1 by 8 plus 1 by 12 plus 1 by 36, this is after simplification, this is 9.3. Let us look at the properties of arithmetic mean and geometric mean and harmonic mean relationship also. See, the AM is greater than GM and GM is greater than HM. So this property is AM is greater than GM is greater than or equal to HM is the important property for the examination point of view also. Now let us look at the MCQs on the related to harmonic mean. If there are two groups with 75 and 65 are harmonic means and containing 15 and 13 observations, then the combined harmonic mean is. Already we know the formula for combined harmonic mean is, suppose two observations are n1 by n plus 2, n1 by h1 plus n2 by h2. This already we have been discussed in the earlier. So here the data is the 15 and 13 are n1 and n2. These are all h1 and h2. This is n1, n2. Now look at 15 plus 13 divided by 15 by 75 plus 13 by 65. This will be 28 by 1 by 5 plus 1 by 5. This is 28 into 5 by 2 and 14 5s are 70. So 70 is the harmonic mean for this data. This is 15 plus 13 28, 28 by 1 by 15 5s are 75, 13 5s are 65, 1 by 5 plus 1 by 5 2 by 5, and this will be reciprocal, and 2 14s 28, 14 5s are 70 is the harmonic mean for this data. Now let us look at the weighted average in the next slide. This is the important concept, and for using the weights are given in the data, then we use the weighted average in the examination point of view also. Sometimes weighted average also very important. Now how the important formulas related to weighted average, let us look at in this slide. When the observations under consideration having hierarchical order of importance, we take, of course, computing weighted average, which is could be either weighted or AM or weighted average. Now, weighted AM is weighted AM. Also, we can find weighted AM for the formula sigma WI XI by sigma WI, where W is the weighted index. In the case of weighted GM, the weighted GM, summation of WI log X by summation of WI, and weighted HM. Weighted HM can be written as summation of WI by summation of WI by XI. An aeroplane flies from A to B at the rate of 500 km per hour and comes back B to A at the rate of 700 km per hour. The average speed of the aeroplane is. Already we have discussed related to the harmonic mean formula for two numbers. When the distance A to B is constant, the same distance A to B to A distance also same. In that case, we apply for the finding of average speed. That harmonic mean for two numbers and the average is 2xy by x plus y. In that case here, this is 2 into 500 into 700 divided by 500 plus 700, and 2 into 500 into 700 by 1200, and this will be 583.33 km per hour is the average. Option 2 is the correct for this question. Students, please note down, when the distance is constant and the speed varies, in that case we apply harmonic mean, and harmonic mean formula is for two numbers for 2xy by x plus y, and this formula is very important for the examination point. Very important. Next, if the AM and GM of 10 observations are both 15, then the value of HM is also 15. AM is A plus B by 2 equal to 15. A plus B equal to 30, and GM of 10 observations, square root of AB is 15, AB equal to 225. Then HM is 2AB by A plus B, then 2 into 225 by A plus B is 30, 2 15s and 15 15s, so HM is also 15. Option 3 is correct one. If GM of X is 10 and GM of Y is 15, then GM of XY is, already we have discussed the property of GM of XY equal to GM of X into GM of Y. GM of XY equal to GM of X into GM of Y. In that case, here GM of X is 10, GM of Y is 15, 10 into 15, 150 is the answer, correct answer. So option 1 is correct. There are two groups with 75 and 65 as harmonic means and containing 15 and 13 observation, then the combined harmonic mean is given by. Already we have discussed the related to formula to combined harmonic mean is n1 plus n2 by n1 by h1 plus n2 by h2. This is the combined harmonic mean formula. In that case, simply we have to apply this 15 plus 13 divided by 15 by 65, 15 by 75, 15 by 75 plus 13 by 65. So this is 28 by 1 by 5 plus 1 by 5, which is 28 into 5 by 2, 5 by 2, that is 70 is the correct answer. That is option 3 is correct. MCQ number 5. What is the HM of harmonic mean of 1, 1 by 2, 1 by 3, 1 by n? The options are n, 2n, 2 by n plus 1, n by n plus 1 by 2. The right option is C. How we can look at it? You know, the series are in the form of 1, 1 by 2, 1 by 3, etc. 1 by n. You know, look at the formula, like that, n by this reciprocal of all these items, 1 by 1, 1 by 1 by 2, 1 by 1 by 3 plus 1 by n is the values. So this will be 1 plus 2 plus etc. n values. This will be n by, you know, sum of the n terms of n AP, that is summation of n, that is n by n into n plus 1 by 2. This can be written as n by 1 into 2 by n into n plus 1. And here n would be cancelled. So the right will be, option will be 2 by n plus 1 for the third one is the option 1. Option C is the correct one. So once again, you look at the series is in the form of 1, 1 by 2, 1 by 3, 1 by n is in the form of sum of first n terms of AP. If we reciprocate the formula as per the harmonic mean formula is n by summation of 1 by x, like that. So here we are also reciprocating all the values of 1, 1 by 2, 1 by 3 and etc. This will be equivalent to sum of first n natural numbers n. You know, sum of first n natural numbers is also n into n plus 1 by 2. This is very important. We applied here in the denomination portion here. After that, this will be n by 1, and if the two fractions are divided, the denomination portion can be written into reverse order. And so here n get cancelled, and rest of the answer will be 2 by n plus 1. If AM and HM for two numbers are 5 and 3.2 respectively, then the GM will be, here AM is 5 and HM is 3.2, and GM we have to find it. You know, two numbers A plus B by 2 is the AM, and based on that A plus B equal to n. Next one is HM equal to formula 2AB by A plus B, and 2 into AB, A plus B value is 10 here, and HM is already given that 3.2. So AB equal to 3.2 into 5, which is 60. So we have to find the value of GM. GM is square root of AB, and square root of 16 is 4. So the fourth one is the right option. Now the harmonic mean of the numbers 2, 3, 5 is, the options are 2, 3.33, 2.90, 3. Square root of 30. You know very well the numbers, three numbers are given. So 3 by reciprocal of these numbers, 1 by 2 plus 1 by 3 plus 1 by 5, and this would be equal to 3 by, which is 0.5, 0.33 plus 0.20, which is 3 by 1.03, and which is equivalent to 2.90, and which is third option is the correct for this question. And students, with this I complete the measures of central tendency topic and wish you all the best for the examination point of view. Thank you very much.